So here we have set 2. For number 5, we have z plus 6 divided by negative 2 equals negative 4. The most common mistake that I see here is that students will immediately see the plus 6, and then they will want to subtract 6 from both sides as their first step. The issue here is that we can't do that because the z plus 6 part is a part of a fraction. So if it's a part of a fraction, we have to get rid of the fraction first. So to get rid of the negative 2 on the bottom, I'm going to go ahead and multiply by negative 2 to both sides. So multiply by negative 2 by negative 2. And by doing that, I'm able to cancel out that denominator, the bottom number of the fraction. So here I have z plus 6 now equals negative 4 times negative 2, which is positive 8. And now I can go ahead and subtract both sides by negative 6 to get z by itself. So 6's cancel, z equals 8 minus 6, which is 2. So z is 2. Same thing for number 6. We have b plus 3 over 5 equals negative 2. Please remember not to subtract 3 as your first step. Again, it's a part of a big fraction, so we need to get rid of the denominator first. So I'm going to go ahead and, to get rid of the denominator, multiply by that number. So multiply both sides by 5. By doing that, the 5s will cancel out. And on the left side, I'm left with b plus 3 equals negative 2 times 5, which is negative 10. And then that leaves me with one more step. Subtract 3. Whatever I do to one side, I do to the other. So b equals negative 10 minus 3, which is negative 13. All right, number 7. So I have x squared minus 12 equals 37. So for this step, or this equation, if I want to get x by itself, I need to go ahead and remove that minus 12. So I'm going to do the opposite of subtraction. That's going to give me plus 12 for both sides. And when I do that, the 12s cancel. And I'm left with x squared equals 37 plus 12. That's going to give me 49. And remember, we learned that if we see a square and we want to get rid of the square or cancel the square, the inverse would be taking the square root. So this is going to give me x on the left side equals two numbers that multiply to 49. That's going to be 7. But don't forget, there's another answer as well. 7 times 7 equals 49, but so does negative 7 times negative 7. That also gives you a positive 49. Okay, so same thing for number 8. X squared plus 4 equals 40. We can start off by canceling that positive 4 by subtracting 4. Whatever I do to one side, do to the other. Positive 4 and negative 4 cancel. I'm left with x squared equals 40 minus 4, which is 36. And if I see a square, what do I need to do? I need to take the square root. So that means on the left side, I have x now, because the square and the square root cancel. And two numbers that multiply to give me 36 would be 6. But again, another solution would be, I know that 6 times 6 equals 36, but so does negative 6 times negative 6. All right, guys, two more. So for number 9, we have negative 5 x squared equals negative 45. So if I want to get x alone, in this case x squared alone, and then x, I need to go ahead and get rid of that negative 5 in front. Technically, it's being multiplied right now. What's the inverse of multiplication? That would be division. So I'm going to divide by negative 5, whatever I do to one side, do to the other. By doing this, I know that the negative 5s will cancel, leaving me with an x squared on the left side. And then negative 45 divided by negative 5 would give me 9. And last step here, to get rid of the square, take the square root. This leaves me with x equals 3 times 3 would give me 9, but so does negative 3. Okay, so the square root of 9 would give me 3 and negative 3. Two solutions. We've made it to the last one for the set. So let's go ahead and cancel the 3 in front of the x squared by dividing. And when we divide, we know that the 3's will cancel, leaving us with x squared equals, and then 27 divided by 3 would give us 9. And then just like number 9, we can see the similarity. Take the square root, and x should equal 3. 3 times 3 equals 9, but so does negative 3.